Okay, Chapter 5, Question 143. We have a mixture of methane and ethane gases with a total pressure of 0.53 bar. Okay, so so let's just put... We're going to put the first pressure to be 0.53 bar. Okay, where are we here? Just enough O2 is added to the mixture to bring about its complete combustion to CO2 and H2O, both gases. The total pressure of the two product gases is found to be 2.2 bar. Okay, so this is combustion. Let's make this reactants. Let's make this products. Both pressures, 2.2 bars. Okay. Assuming constant volume and temperature. Okay, so volume and temperature are going to be constant. Find the mole fraction of methane in the mixture. Okay, so this is going to be rather similar to some of those algebra problems that we were doing in Chapter 2 and Chapter 3, but instead of moles, we're going to be using partial pressures. In this case, so we really kind of have two combustion reactions going at the same time, and we have to write these separately because there's oxygen added. So there's oxygen added in this partial pressure here. So we can't just use the two pressures directly to get the mole fraction. So we're gonna have to work this a little bit differently. So first, let's write the one for methane. So CH4, all right, we're going to have to keep track of gas products and such. So CH4 gas plus some amount of O2 gas. We're going to balance this thing. All right, burns to form CO2 gas and H2O. Okay, balance. So the C's are good. 4 H's, so 2 of those. All right, so that means we got 2 oxygen. 4 oxygen means 2 there. 2 there. And we're good just like that. All right, now let's do the ethane. So ethane is C2H6, also gas. That's got some amount of O2. That also burns and produces the same products. Okay. And now let's balance this one. 2 carbon and ethane means 2 of them in carbon dioxide. We have 6 hydrogens here, which means we need 3 of these. Okay, it makes a total of 3 water here, and 4 makes 7. So 7 divided by 2 here. All right, we're going to keep this to a stoichiometric value of 1. You're going to see why in a minute. Okay, so first we're gonna write out our partial pressures here. So the partial pressures of these two initially, right? Because these two are initially in a mixture all of their own, right? This oxygen is introduced after the fact. So our first expression is the partial pressure of CH4 and the partial pressure of ethane, 6. And this is equal to this here, to 0.53 bar. Okay, so the one that we want is ethane, or methane, excuse me. This is the one that we want. So we're going to call this X, and we're going to solve for the partial pressure of methane that way. 0.53 minus X, just like that. So then when we're writing out our like product reaction time the partial pressure expressions, we're going to sub this in for this one here. We're going to sub this in for the partial pressure of ethane, And we're going to end up with an expression that we can solve for x later on when we put the product values into the expression. All right, let's do this. So I'm just going to put this over here. Pressure of ethane equals 0.53 minus x. All right, let's erase some room and keep on trucking. Okay, so first let's solve for the partial pressures of both of them. All right, so from CH4 here, let's do that one first. So for CH4, we have X. That's what we've assigned. That's what we've assigned it here, right? And that's going to be multiplied by the moles of gaseous products, right? Divided by the moles of gaseous reactants. That's just terrible. Okay, and again, oxygen is not in this. We're talking about this initial one here with 0.53 bar, so don't look at the oxygen here at all. So we have 1 mole of reactants. We have 3 moles of products, right? So that means that this is going to be equal to x times 3 over 1 is equal to 3x. All right, so there's our methane. Now let's do ethane. So C2H6, all right, again, ignore the oxygen. We have 1 mole here of 1 mole of, good grief, reactants, and 5 moles of gaseous products. Got 2 of carbon dioxide, 3 of water. And remember, we've solved for this as 0.53 minus x. So this is going to be equal to 0.53 minus x times mole products over reactants. I'm going to skip right in this here, right? So we have 5 moles of gaseous products and 1 mole of gaseous reactants. It means that we're just multiplying this thing by 5. All right? That gives us a total of 2.65 minus 5x. And that's our expression for the partial pressure of ethane. Yeah, these are both partial pressure expressions. Okay, so I'm going to write that over here quick. 2H6 equals 2.65 minus 5x, and of CH4 equals 3x. Okay. All right, so now we're going to write an expression for this, for the product pressure, right? And we're going to sub both of that. We're going to sub both of those values in and solve for x. So we have products of methane plus the partial pressure of ethane gives us 2.2. This is going to be 3x plus 2.65 minus 5x equals 2.2. We're going to collect like terms. All right, gives us negative 2x equals negative 0.45. 45. Solving for x gives us 0.225. And there we go. So x was our partial pressure of the initial mixture for methane. All right, so now all we have to do is solve for the mole fraction. That's what the question asks for. Now, remember, because we have volume and temperature is constant this whole time, and obviously R is constant too, right? So that means that this here, right? Partial pressure of CH4 over the total pressure. This is the same as this, right? Which is, moles of methane over the total moles, right? These become directly proportional if the rest of these things are held constant. So get rid of this bit here, and we can just solve this expression here. So this is going to be equal to the partial pressure, which was 0.225, right? And we can, well, don't have to put the units back in, but this would be bar. Might as well. And we divide that by this pressure of the reactants, 0.53 bar. All right. And that gives us a mole fraction of 0.42 for methane.